The following video asks us to solve a quadratic equation by graphing. Well, when you solve a quadratic equation by graphing, you're relying on the idea that we're going to set it equal to y instead of 0. You do this because then all we have to do is determine where on the graph is y equals 0. Well, that's a very specific place, and that is the x-intercepts. So what you do is you graph your quadratic equation, or your parabola, as we call them, and look for the x-intercepts. That's the goal. So we got to go about graphing this quadratic equation. And then once we do that, then we identify the x-intercepts. So we use the method of finding the vertex by x equals negative b over 2a. That is the x-coordinate of the vertex. A is what's in front of the x squared, which is 1. B is what's in front of the x, which is 6. So we plug those into the formula. You get negative 6 over 2, which equals negative 3. So what we've discovered is the x-coordinate of the vertex. And so you can begin to create your t-chart. Well, you begin by placing that negative 3 right in the middle. And in the middle such that you can have 5 points, so 2 above and 2 below. And then you count up, negative 2, negative 1, right? You're counting, as you count up negative, you go down in number. Then you count down, negative 4 to negative 5. Then we're going to go through and we're going to plug these values of x into the equation. So we're going to put negative 3, we start with the vertex usually. Negative 3 squared plus 6 times negative 3 plus 10. Well, negative 3 squared is 9. 6 times negative 3 is a negative 18 plus 10. Well, that becomes, well, it's going to be 9 plus 10 is 19, minus 18 is 1. So I put negative 1 in, I get 1, or negative 3 in, I get 1 as an answer. Now I'm going to put negative 2 in. You get y equals a negative 2 squared plus 6 times negative 2 plus 10. So it'll give you 4 plus negative 12 plus 10. So you get 14 plus negative 12, which would equal a positive 2. And if you remember, there's a symmetry that happens. So we found out what y equals when we have negative 2. That would be 2. Well, that's going to be the same as it is for negative 4 because of symmetry. And then you plug in negative 1, and you get y equals a negative 1 squared plus 6 times negative 1 plus 10. And that's going to give you, well, negative 1 squared is 1. So equals 1 plus, well, 6 times negative 1 is a negative 6 plus 10. Well, that gives you 11 plus negative 6, which is 5. And that holds for negative 5 as well. If you plug negative 5 in for x, you would get 5 out for y. All right, so let's go take a look at what our graph looks like. So we're going to go over to the right and plot these points. Well, something interesting happens. So we put negative 3, 1, we graph the vertex first, and then negative 2, 2, and negative 4, 2, and then we go to negative 5, or negative 1, 5, and negative 5, 5. And you might notice, remember, we weren't trying to graph this. That wasn't our goal. Our goal was to find the x-intercepts. Well, an x-intercept is where does this graph intersect the x-axis? Well, the answer is nowhere. It doesn't intersect that x-axis anywhere. So that means you have no x-intercepts, which means you have no solution. There is no value for x that will make that equation true. You can't find anything for x that will make it work out. There's no values at all to get 0, and so the answer is no solution.